Hey y'all, this is a quick, well, see how quick it is, video lesson for those of you who have missed the last couple of class periods where we talked about momentum. The first thing that you need is vocabulary. So take a few seconds, hit pause, and get all of this vocabulary. Okay, once you've got that, I want you to pay attention to one particular word in here, inertia. Now, right here is this definition of inertia. It's going to remember what that means. Inertia is a resistance to a change in motion, and we measure that change in motion, the resistance to a change in motion, with mass, which means momentum is truly mass in motion. All right, so that's what we're going to be talking about. We're going to cover momentum and impulse. Then we're going to talk about conservation of energy and how it pertains to kinetic energy. And then we're going to go into a couple of types of collisions, inelastic and elastic. But for today, we're just sticking with momentum. All right, so note-wise, here's our basic concepts. Momentum is a property of moving things. It means inertia in motion, which we just talked about, where inertia is basically we're talking about mass in motion. Think about this like this: mass in motion. You see a train coming at you, that is mass in motion. It has a lot of resistance to changing its motion. It is the mass of an object multiplied by its velocity. It is a vector. It matters which way that momentum is going. You're going to see that as we get through some of the math and with some of our examples as we talk about impulse. Okay, it can be, momentum can be transferred. Okay, that's going to come up when we talk about conservation of momentum. You can transfer it from one object to another. Now, in equation form, momentum is equal to mass times velocity. Looks like this. No, I do not know why momentum has the unit of P. It just is. There's all sorts of stories. The closest one I could find was something involving Isaac Newton and pimentos. So we're just going to leave it at P. The unit for this is going to be, all right, look at our units for mass. Our unit for mass is kilograms. Think back to last semester. Our unit for velocity is meters per second, which therefore means that our unit for momentum is kilogram meters per second. Again, this is momentum. This is mass.
Oh, it's Daddy.
I'm talking to Mom.
And give me a second, guys, okay? All right, got little kid stuff. And here's our velocity. Okay, so that's basically the big idea behind momentum. Let me see. What about that one? This one. Okay, here's a big deal. I want you to pay attention to this. This should get written down. When the speed of an object is doubled, what happens to its momentum? Now, if you think back, we did something like this when we talked about kinetic energy. What happens to, if you double the velocity, what happens to kinetic energy? Well, same idea here. It's actually a little bit simpler. Take a look at the equation where momentum is equal to mass times velocity. Now, in this equation, if we're looking at the speed and the momentum, that means that we don't really care about the mass. The mass is going to stay constant, which means that momentum is proportional to velocity. Specifically, we could say that it is directly proportional to velocity. So if that's directly proportional to velocity, then let's see what we need from there. Directly proportional means that when one thing changes, the other thing is going to change the same way. So if this right here is a true statement, and we're going to change one of those variables, we're going to multiply it by 2, what has to happen to the momentum to make this a true statement, to keep it a true statement? Well, it means if we double our velocity, we have to double our momentum. Okay. By the same token, as a feature of being a direct relationship, if we cut our velocity in half, we'll cut our momentum in half. Just direct relationship. I think you can see it's a little bit easier than dealing with the squared. But it's the same idea. Okay, so I want you to try some stuff here. I want you to take a few seconds. On the left-hand side of your paper, I want you to write these 5 statements, and I want you to determine if they are true or false. If false, all right, I want you to correct it. So you're going to write all 5 statements. The false ones you are going to correct. Okay, and we'll go over that when I see you in class next. Let's do a couple of examples here. Here is our first example. We are going to calculate the momentum of a 92-ton train traveling at 80 kilometers per hour. Just like always, we write our variables down. What? Look at my phone. My phone. All right, so we're going to calculate the momentum. That means we need to find P. 92-ton train. Look how they use 92-ton as an adjective. That means what they're talking about there, they're basically talking about tons as a mass. We also have our velocity is at 80 kilometers per hour. Okay, so honestly, this is a pretty straightforward. We have a mass, we have a velocity, so we can go ahead. Not right now, sweetheart. All right, we can go ahead and kind of plug and play. The issue, though, is, if you remember, is that the units for momentum are kilogram meters per second. Just 1 second, guys. So let's keep going with this. So what I was saying was that momentum has to be in kilogram meters per second, and this is not, so we have to do conversions. Ton, 1 ton is equal to 1,000 kilograms, which means if you have 92 tons, we're talking about 92,000 kilograms. 80 kilometers per hour, we're going to need to convert that, kind of do the train track method here. We're going to start by copying and pasting the top unit, kilometers, down below. So, and then we want to take kilometers, we want to get that to meters. Kilometers are bigger than meters, so that's a 1, and there are 1,000 meters in every kilometer. Kilometers on top will cancel out our kilometers on bottom, leaving just meters. Now we can fix the hours. We're going to take the hours, we're going to copy and paste that up top, and we can convert that to minutes. We'll do the same thing, we get it to seconds. So copy and paste the minutes up top. We can take minutes to seconds. So 1 hour has 60 minutes, and 1 minute is 60 seconds. So if we do that math, we're going to end up with, so when you do that conversion, you end up with 22.2 meters per second. So now that we have our conversions made, we can go ahead and plug it into the equation where P, momentum is equal to mass times velocity. So it's going to be momentum is equal to 92,000 kilograms times 22.2 meters per second, and that's going to give us 2,044,444 kilogram meters per second. All right, there we go.